Following on from the previous video, we were trying to understand this function here. We were trying to understand this function. In the previous video, we looked at this. We looked at f prime. F prime gave us this graph here, and then from this graph here, we can deduce something about our original function. Okay, so f prime looks like this. Now let's go back one step and let's look at these conditions here. In one of the earlier videos, from this we managed to deduce these. Now this thing here, the f of 0 is 0. So f of 0 equals 0 means this. Now f of 0 equals 0 means this. This is f, the normal f without the prime. F of 0 equals 0 means that the function here must cross over here. Okay, that's what it means here. F of 0 equals 0. It means it must be on the origin. And looking at this here, it means that the gradient at 0, it must be 1. It means that the gradient here, must be 1. Okay, and then looking at this here, looking at this here, it means that there's something fishy going on at it means that there's something strange going on at x equals 0. It turns out to be an inflection point, but let's just pretend we didn't know that. Something funny going on at the origin. Okay, but from these conditions here, we can deduce that it crosses at the origin, has a gradient of 1, and there's a point of inflection at the origin. Okay, and then in the previous video we established that there was an asymptote here and an asymptote here. So our graph looks something like this. Okay, so our graph will look something like this. The other thing that we need to look at is this. Now let's look at f double prime. This would tell us whether it concaves up or down. And then, we know that this here could be a station, a turning point. Well, from this we can tell that it turns out to be an inflection point. So let's look at this. Let's look at f double prime now. So f double prime, looking at f double prime. So looking at f double prime, if you look at when x is positive, if you put a positive number into here, when x is positive, this whole thing here will be positive. Okay, because if you put a positive number, if you're in the positive realm, put it into here, this whole block here will be a positive. But then this thing here will be a negative. So when you're in the positive region, f double prime will be a negative. Will be a negative. Okay, and then if you're in the negative realm, if you put a negative number into here, this block here will be positive. This whole block here will be positive, but then this block here you've got a negative, and because x is in the negative realm, this block here, the whole block here will be positive. So when you're in the negative realm, f double prime will be in a positive realm. So what that means is when x is positive, the original function f of x, the original function will concave down. Okay, so when x is in the positive realm, when x is in the positive realm, capital F of x, the original function should concave down. When you're in the negative realm, the original function should concave up. Okay, it should concave up. When you're in the positive realm, the original function should somehow concave down. Okay, concave down. So if you look at this here, this is actually true because hang on. Well, when you're in the negative realm, it should concave up, which it does. It concaves up. Look, it's concaving up. And then when you're in when x is in the positive realm, it should concave down, which is the case. Okay, and hang on, and because when you look at f double prime, over here it's positive, over here it's a negative, then that must mean there's a point. This must be a point of inflection here. It's not a turning point. Okay, and we've done several videos on sketching graphs. You should have mastered this skill by now. Okay, so everything supports that our original function f of x should look like this. Okay, so from just this, so from the very beginning, all that was given to us was this. From this, we can deduce this, we can deduce this, we can deduce this whole thing here, and then looking at this, we can then sketch our original function. So this here is another way of expressing a function. You can express a function as an integral. Okay.